Hi guys, this is your Exponent and Poly applications. Hopefully I can do this in one video. If not, there will be a part 2. So just going right into it. Number 1 is from last week's Delta Math. You're subtracting trinomials together. So this one is a trinomial. And it's being subtracted from this trinomial here. So remember the order flips. So 8x squared minus 3x plus 7 is what you have originally, and you're subtracting that negative 2x squared plus 3x minus 9. All right, so remember there's that 1 that we do not have to write, so we're really distributing a negative 1. All that really means is the signs are going to flip. All right, so 8x squared minus 3x plus 7, so I'm just rewriting that. Negative 1 times a negative 2 gives you a positive 2. X squared just comes along for the ride. Negative 1 times a positive 3 gives you a negative 3x. Negative 1 times a negative 9 becomes a positive 9. All right, and then you're going to combine like terms. So start with the highest exponent. So highest exponent is 2. You are just adding the numbers, all right, because that is your operation. You're either going to add or subtract, all right? So 8 plus 2 gives you 10, and the x squared just comes along for the ride. It does not change, all right? So your next one would be negative 3x. And this negative 3x, all right, their exponent is 1. You don't need to write it, but you can if you want to. So 1, 1, so you can tell that they're the same. Again, you're just combining like terms. So you have negative 3 minus 3, that gives you a negative 6, and that x raised to that first power comes along for the ride. Okay, so that one. You don't need to write the 1. All right, last but not least, we have our constants. All right, those are the numbers without variables attached to them. So 7 plus 9, that gives you 16, and that is going to be your final answer. Number 2 is a question from this week's Delta Math. So we are going to just use that distribution property plus in addition to the exponent rules. All right, so we are multiplying. That's what the parentheses means. There is no symbol in the middle, so we just assume that it is a multiplication. All right, so 2 times 9 gives you 18. So times, well, you have x cubed times x squared. That's the x squared right here. So I'm just going to combine them because they are or rewrite them next to each other, so I can go ahead and multiply. So when I multiply with exponents, you add the exponents. So when you multiply, when your operation's multiplication, you add the exponents, and then you have times y. So we're going to go ahead and clean this expression up. So we have 18x to the 5th power, and then y. We don't need to write those little dots. That's why you have the numbers next to the variables next to the variable. All right, so that's it. Number 3, this is where we get into applications. So we're going to we're going to find the perimeter and the area. So we're going to start with the perimeter first. So perimeter equals all the sides added up. So all sides added. That is how you find the perimeter of any shape. So a square is nice because a square has equal sides. So if this side is 5x, all the sides are 5x. Okay, so really you're going to do perimeter equals, well, it's just all the sides. You have 4 sides. So you're going to add 5x 4 times. So you're just adding. So you're adding the coefficients. So 5 plus 5 plus 5 plus 5 gives you 20, and the x just comes along for the ride. Okay, you're not adding the exponents, you're not doing anything, the x just comes along for the ride. Okay, that is the longer way of doing perimeter. The shorter way to get the same answer, remember I told you there's four sides, right? There's 4 sides and they're each 5x. So really that's 4 times 5x. So instead of adding the 5x 4 times, you can multiply 5x by 4. When you multiply, you just multiply the numbers. So 4 times 5 is 20. The x doesn't have anything to multiply with, so it just comes along for the ride. So you get the same answer. So whether you want to do it the long way, the short way, you still get the same answer. All right. Next, we're going to deal with area. So area equals length times width. In our case, it doesn't matter which side we notate as length and which side is width, because they're actually going to be the same, because it's a square. So when we rewrite this, it's going to be 5x times 5x. All right. So that gives us exponent rules. We multiply the numbers. 5 times 5 is 25. Then you have x times x. So you're adding the exponents here, because your operation's multiplication, you add the exponents. So x is your base, 2 is going to be your exponent, because 1 plus 1 is 2. All right, there's also, again, another way to do this version. So this is actually the same as saying it's 5x. If you're multiplying a number by itself, you use exponents to signify that. So you're multiplying 5x by itself twice. So you can raise 5x, that monomial, that one term, to the second power. So when you have a quantity raised to the second power, you distribute that squared. So really you're going to do 5 squared times x squared. All right, so that gives you the same answer, 25x squared. Okay, so whichever way you want to do it, your answer is still going to be 25x squared. Okay,